Right, guys, we'll come to the question number 2, and there it is asking about the relations. Now, you want to understand what are these three relations, which the names are reflexive, symmetric, and transitive. And we have to justify each of these things. Okay, first of all, we'll understand what is called this reflexive, what is called this symmetric, and what is called this transitive. And okay, first of all, the reflexive. Okay, I will write here uh, reflexive. What do you mean by reflexive? Reflexive, that means every element is related to itself. That means now they have given a set a equals 1 2 3. Each of those elements, if those are related to itself in the relation, we are calling it as reflexive. That is, every element is related to itself. Every element is related to itself. But we want to understand this thing mathematically. That means relationship normally we will denote by the ordered pairs. If related to itself means A related to A, that means pointing to itself. 1 is related to 1, 2 is related to 2, 3 is related to 3. That means in the ordered pair, the say if it is related to the same element. That means in mathematical we are telling it as a a comma a belongs to R. Belongs to R means the relation. Okay, belongs to R for all A belongs to A. That means, what do you mean by that? For all, that means each of the elements belongs to A. That means A is here 1 2 3. Okay, A is here 1 2 3. If all of those relations, all of those elements are related to itself, we are calling it as reflexive. That means all the element in set A, if those are related to itself, everything is related to itself, then means it is reflexive. So how do you find out this one? Now, when you find out this one, we want to first consider about the set. The given set is 1 2 3. Okay, and we have to consider all the elements in this A set. Those, what are those elements? 1 2 3. And we want to check whether, okay, in our relationship all these things are available. That means what are the ordered pairs we can write from this thing? 1 comma 1. We want to check whether is that belongs to R. Okay, and we want to check what is the other one, 2 comma 2, because 2 also should be related to itself. Okay, belongs to R. That means we have to check whether 1 comma 1 is in the relation, 2 comma 2 is in the relation, 3 comma 3 also in the relation. If these three things, now if there is a another element called 4, 4 comma 4 also should be in the relation. If these three things, okay, because in our set only three elements, okay, 1 2 3, so 1 comma 1 belongs to should be belongs to R, 2 comma 2 belongs to R, and 3 comma 3 belongs to R. If those three things are satisfied, okay, then we can say it is reflexive. Now what is the given relationship? That is R1. Okay, R1. Now R1, you can see 1 comma 1 is there, okay, that is satisfied. 2 comma 2 also there, that is also satisfied. 3 comma 3 also there, that is satisfied. That means all these three things are satisfied according to this A set. Okay, and in addition to that, this 2 comma 3 also there, 3 comma 1 also there, 1 comma 3 also there. You can have any additional things, but the thing what you have to satisfy is all the elements should be related to itself. Now these things are already there, so we can say it is reflexive. Okay, so how do you say that one? 1 comma 1 belongs to R. We want to write like 2 comma 2 belongs to R. That is also there because in R we can say R means R1, okay, the first relation, okay, R1, okay. In 1 comma 1 belongs to R1, that is satisfied. 2 comma 2 belongs to R1, that is also satisfied. 3 comma 3 belongs to R1, that is also satisfied. You don't want to write 2 comma 3 3 1 and 1 comma 3, because what you want to check only these three things, okay, because in our set there are three elements, 1 2 3, and itself means 1 comma 1 2 comma 2 3 comma 3. Since these things are satisfied, we can say it is reflexive, okay, it is reflexive. The first one is reflexive, okay, that means R1 is reflexive. The relation is reflexive, right? Then we want to check for this R1 whether it is symmetric. What do you mean by symmetric? Symmetric means that means if there is A comma B belongs to R, then B comma A also belongs to R. That means if something in pointing like this way, I will write. Now we'll consider about the symmetric. Symmetric means if A comma B belongs to a relation, then what do you want to have? Then B comma A, that means reverse also should be okay. If A comma B belongs to R, then B comma A also belongs to R. That means R means not real numbers, R means the relation. If A comma B belongs to the relation, then B comma A also should be related to the relation. Okay, now see about the R1. R1, here we can say 1 comma 1 is there. The reverse of this one also okay, right? 2 comma 2 also there. 3 comma 3 also there. Okay, then after that 2 comma 3 is also there. Now if 2 comma 3 is there, 3 comma 2 also should be in the relationship. Can you see the 3 comma 2? No, you can't say. And 3 comma 1 also there. Then 1 comma 3 also should be there. But you can see 1 comma 3 also there. But only the problem is this one. What is happening? Okay, you can say to have the symmetric, what do you want to say? The first you want to write this thing. If A comma B belongs to R, then B comma A also belongs to R. But in our case, 1 1 2 2 3 3, all those things are related to R. Okay, here 1 comma 1 belongs to R1. 2 comma 2 1 comma 1 belongs to R1 means what do you mean by that one? This belongs to the reverse of that one also. Okay, the other one also okay. 2 comma 2 belongs to R1. The reverse of that one is the trivial 2 comma 2 R1. 3 comma 3 also belongs to R1. Their reverse also okay. But the problem is 2 comma 3 is available in the R1. But can you find 3 comma 2? 3 comma 2 is there? No, there is no 3 comma 2, right? This doesn't apply. Okay, so you can say since 2 comma 3 belongs to R1 and 3 comma 2 not belongs to R1. This is not reflexive. This is not symmetric. Not symmetric. If one is missing, you can say that it is symmetric. Okay, if one is missing, you can't say that it is symmetric. So 3 comma 1 is satisfied, and because 1 comma 3 is also there, but only the problem is 2 comma 3 is belongs to R1, but 3 comma 2 is not belongs to R1. This is not symmetric. Okay, so we have proved the reflexive thing and the symmetric thing for the R1. We'll see the what is transitive. Okay, we'll see how to prove the transitive. Right, now transitive, the same manner we'll define what is transitive here. Transitive. What do you mean by transitive? Transitive means in the ordered pair, if A comma B belongs to R, and after that will the ending pair element is B, we'll take another one like C. B comma C also belong to R. Then this should imply A comma C belongs to R. Okay, that means if A comma B is in the relation and B comma C also in the relation, then A comma C also in the relation. Okay, A to B, B to C, then A to C also in the relation. So then we are telling that it is transitive. Transitive is very simple. What do you want to understand? Start from something, end with something. The ending thing again arrow to another one, like A comma B, ending is B, B comma C, then A comma C. All those three things are available in the relationship. Then we are telling that it is transitive. So if we consider about this R1 relationship, you can say 1 comma 1. You can say 1 comma 1. It is transitive because 1 comma 1. You can say like it is something like this way. Okay, 1 comma 1, 1 comma 1. Ending is 1. Okay, so next ending also 1. So that means it is the other part also 1 comma 1. That means if it is ending with the same thing, we can say it is transitive. Okay, transitive. Okay, the similar numbers, if those are present, those are transitive. Like that, 2 comma 2 also transitive, 3 comma 3 also transitive in relationship 1. But now you can see about the 2 comma 3 and 2 comma 3 and 3 comma 1. Okay, 3 comma 1 is there. Okay, now consider about this one, 2 comma 3 and ending with 3, then 3 comma 1. Then you want to say about 2 comma 1, that is that present? Yeah, 2 comma 1 also present. No, 2 comma 1 is not present, right? 2 comma 1 is not present, so you can't say that this is transitive. The reason is what? 2 comma 3, 3 comma 1, 2 comma 3, 3 comma 1, 2 comma 1 should be there, but 2 comma 1 is not present. And you can see there 3 comma 1 is there, 1 comma 3 is there, 3 comma 3 is there. So from these two you can find out 3 comma 3. Okay, but the problem is with 2 comma 3 and 3 comma 1. So what do you want to say about the transitive? You can say you don't want to say about the other things. Okay, 1 1 2 2 3 3, those are itself it is transitive. You can find out the count example. Count example means you have to find something which is not satisfying. So this thing 2 comma 3 and 3 comma 1, you can say 2 comma 3, you can say 2 comma 3 belongs to R1. Okay, and 3 comma 1 also belongs to R1, but 2 comma 1 not belongs to R1. 2 comma 1 not belongs to R1, therefore not transitive. right. Now we found that the R1 is we have found that it is reflexive, and R1 is also we found that it is not symmetric. The reason is 1 1 2 2 3 3, those things are symmetric, but when considering 2 comma 3, there should be available 3 comma 2 as well. 3 comma 1 1 comma 3, that is available, but 2 comma 3 is not available. 2 comma 3 is available, but 3 comma 2 is not available, therefore it is not symmetric. And when consider about the transitive means if a comma b is available and b comma c is available, then a comma c also available. According to that, here 1 1 2 2 3 3, those are satisfied, but 2 comma 3 is available, 3 comma 1 is available, therefore 2 comma 1 also should be available, but 2 comma 1 is not available, therefore we can't say that it is transitive. So then we will consider about this R2 thing. There in this R2 relationship, there are 2 1 and 1 comma 2 is there, but the problem is in our set is a equals 1 2 3. Since the set is 1 2 3, you want to have all these three elements in order to have the reflexive. What do you want to have? 1 comma 1 should be belongs to R2, and 2 comma 2 also should be belongs to R2. 3 comma 3 also should be belongs to R2. But here what is available? This 1 comma 1 is not available, 2 comma 2 also not available, 3 comma 3 also not available, therefore it is not reflexive. So in R2, if you want to say about in R2, if you want to say about R2 is reflexive, what do you want to check? You want to check the given set. Given set is A equals 1 2 3. The given set is A equals 1 2 3. I equals 1 2 3. In this given set, you want to check each of these elements are related to itself, okay, but and check whether those are available in R2. But you can say 1 comma 1 not belongs to R2, and 2 comma 2 is not belongs to R2, and 3 comma 3 also not belongs to R2. None of these things are inside of this set relation R2, therefore this is not reflexive. To have the reflexive in the set, all of those things are each of the elements in set should be available in the relation. So it should be related to itself in the relation. So in R2, those are not included, so therefore it is not reflexive. And you can check whether it is symmetric or not. To check the symmetric, now 2 comma 1 is there, belongs to R2, then you want to check whether 1 comma 2 also belongs to R2. Is that there? Yeah, because 2 comma 1 is available in R2, 1 comma 2 also belongs to R2. You want to check the other side also. Now we have checked the 2 comma 1 is belongs to R2, then 1 comma 2 is also belongs to R2, that means it is symmetric. Then now you check with the 1 comma 2. 1 comma 2 related to R2, check about 2 comma 1, reverse of that one. 2 comma 1 also belongs to R2. You want to write both of these conditions, okay? Since those are satisfied, you can say it is symmetric. This symmetric, okay? Then so how about checking the transitive? So transitive is what? When 2 comma 1 belongs to R2, and you want to find the ending is 1 comma 2 this 2 comma 1 is there, okay, then after that ending is 1 comma 2, that is also belongs to R2, but you want to find another one, that means starting from 2 ending from 2, then 2 comma 2 also should be present in R2, but it is not, it is not available. 2 comma 2 is not available in R2, therefore this is not transitive. This is not transitive. Is that clear? If 2 comma 1 is present, okay, the ending is 1, then 1 comma 2, that is also present, but the starting is 2, ending is 2. 2 comma 2 should also be in the R2, but it is not, therefore it is not transitive. Okay, okay, so in the relation R2, it is not reflexive because 1, 1, 2, 2, 3, 3 are not present, and this is symmetric. The reason is 2 comma 1 is there, the reverse is 1 comma 2 is also there, then if 1 comma 2 is there, 2 comma 1 also there, so it is symmetric. When checking the symmetric, you want to, while checking one ordered pairs, you want to check the other thing also, right? Okay, now we'll check about the R3. R3 is given as R3 is just given as 2 comma 2. Okay, what you can say about this one? Now our set is 1 2 3, a equals 1 2 3. You can say that 2 comma 2 is there, but you want to have, since there are 3 elements, you want to have 1 comma 1 not belongs to R3, and 2 comma 2 it is belongs to R3, but 3 comma 3 also not belongs to R3. Therefore this is not reflexive. As I told, if one also missing, you can't say it is reflexive. Okay, you have to have all the elements. Okay, you want to have the reflexivity for all the elements. Okay, because there are 3 elements in set A, so all those 3 things should be available in the relationship. Okay, so it is not reflexive. What can you say about the symmetric? Symmetric, when considering your the taking the relationship 2 comma 2, we know that 2 comma 2 belongs to R3, and the reverse of this one also 2 comma 2, that is also belongs to R3. Okay, then we can say it is symmetric, because if it is going to the same thing, it is always symmetric. Only one is there, 2 comma 2 belongs to R3. When we reverse in that one, that is also getting the 2 comma 2, it is belongs to R3, so it is symmetric. What can you say about the transitivity? Now 2 comma 2 belongs to R3. Now we have to, now since there is only one ordered pairs, okay, 2 comma 2, so we'll take another one. Next thing also ending is 2. We just assume in 2 comma 2, that is belongs to R3. The reverse one is also 2 comma 2. So starting is 2 and ending also 2. Then 2 comma 2, that is also belongs to R3. That means if it is the same, going to itself means it is, if only one is there, so you can say it is transitive. Okay, it is transitive. Okay, if only one ordered pair is available and it is going to itself, that means it is transitive. Okay, so in the R3 relation, you can say it is not reflexive, as the element, the set A has 3 elements, so it is here it is given only one, so it is not reflexive. But when you consider about the symmetric, 2 comma 2 and the 2 comma 2, the reversing order, you can say it is symmetric. When considering about the transitive, 2 comma 2 starting 2 ending 2, so 2 comma 2, that is belongs to R3. The next reversing also 2 comma 2 is belongs to R2, that means starting and ending also 2 and 2, so it is transitive. So I think we have clearly explained the things. So this is the way we are identifying reflexive symmetric and transitive.